Hi, can you hear me at the back? You okay? You might want to swap places with someone who can't later on. That's absolutely fine. As Hannah said, there's a few warnings that I'm going to give you before I go into the presentation in the main. How many of you are concerned about cloud security? How many of you have no concerns about it whatsoever? It's a done deal. All right. How many of you think that I know the answers? Oh boy, we're in trouble. Okay. I'm going to start with a few warnings. I am not a Chief Information Security Officer or a Certified Information Security Professional or any of these things. So if you hope that I've got the answers, bad luck, you're in the wrong presentation. Also, although these logos are up here, the views that I share with you today may not reflect those of my organization. I'm doing that specifically because there's a camera up there and they're going to be capturing everything I say. I do believe that I am an anti-social networker, and I will explain that a bit later on. Those of you that saw the Microsoft presentations this morning will have seen, I've got to remember the guy's name, Dave Coplin, talking about the use of things like plugging in your own computers and how to secure that, and that was a done deal. There are things that I believe should be done in the right business context. And so I would like to see him attending his business meetings wearing underpants if that's how he watches his television. I think there's a business ideal here for how people should behave, and that's normal governance, normal procedure. I did put this together at short notice. I have been helped by Google Images. So there are going to be some things that flash up there. I hope they're visible. Some of them will make sense. Some of them are just for fun. You decide. I do have a tendency to embellish, to elaborate, to expand, to use the thesauri, to occasionally go off on tangents and sometimes stay there. Some of the stuff may get skipped because we're tight on time. Just follow me, see what happens, see where I end up. You may end up in the same place. You may end up with completely opposite opinions. Fantastic, I'll have done my job. I don't promote any particular cloud provider. I'm not here to sell you a cloud. You can cheer if you wish. I have received some small amounts of funding, very nominal amounts, from one particular cloud provider who I am prepared to say positive things about. If you are a cloud provider and want me to say positive things about you, give me bigger grants. Right. In trying to set this up, given that it was short notice, I thought, well, what is this about? You know, cloud security, what is it? If you read on page 8, cloud security is a concern for 77% of respondents to an IBM survey, 50% expressing worries about data breach or loss. I'll come on to that in a moment. IBM have solved it, so that's okay. They give you private clouds. That does the deal, right? I'm not sure that we're there. Security is definitely an attitude to cloud, and it's an attitude that falls into two camps. Those that have a sense of what they want to do and aren't too concerned about it because they know what they're trying to achieve, and those that say don't go near it, it burns, it's hot, it's fire. I'm going to use these to key the slides that I've got to show you where I think some of these things are. Some of them will be in this category, some of them will be in this, some of them will transition one to another, and we'll variously see what those are. When we're in the panic world, we're all doomed because things fail, right? Amazon fails, we're all doomed. Responses to such panic, apart from pressing panic buttons, tend to be physical. People sweat, people have chest pain, and according to this, people have decreased sex drive. So if you're panicking about cloud use, people may accuse you of certain things. I'm not going to do that. This is probably the message. Don't panic. But the real question for people is this one. Is cloud security really any different to the security of any network-attached device? Once you've exposed interfaces to the world, you have an issue to manage. And the question is, how well do you manage that? Now, being a good academic, I'm going to say, yes, it is, and no, it isn't. Yes, it is pretty much the same, but there are new avenues of attack that it opens up, ones which you may not have necessarily come across. In dealing with cloud security, most of what you'll come across, and we've seen this today, CIA, confidentiality, integrity, and availability. Within confidentiality, I'll also come on to this, data breach, information leakage and leak detection that was mentioned in relation to the IBM stuff. Three other letters that people will use in relation to doing some of this: authentication, authorization, and accounting. Some people will add the two together, put anonymity in it, and come up with CI5A. Choose your acronyms, say what you want about them. This CI5A is in this paper by Talukder, Zimmerman, and Pralahad, Cloud Economics Principles, Costs and Benefits, which is featured in this lovely book. I am promoting something. This is my first shameless plug. There are about 3 of these. There's a chapter in there dedicated to cloud security. I'm not selling it, Springer are. That's my get out for that one. I'm going to pick up on availability, because we have heard about things failing. And we've also heard that you should expect it to fail and you should engineer for it. You should design for it. You should expect it's going to happen. If it's in your internal systems, at some point it's going to fail. What do? If it's in external systems, you should also engineer it for failure. Everything fails all the time. We lose whole data centers. Those things happen. Right? CTO for Amazon.com says this. People need to think not just about putting stuff in the cloud, but about building it for the cloud. And there's a nice comment that I'll also mention in a few moments on this. So we know about the AWS outage. US East had a problem with its elastic block store volumes. Lots of customers were affected. Lots of customers were not affected. Now, the panic state depends on which group you're in for those. So Foursquare, Reddit, and others were dead for the period. They hadn't engineered around failure. A comment that I've heard, and I'll say privately who it came from, I've put asterisks in there. You can insert your own word that is a synonym for sewage. If it's sewage in your backyard, it'll be sewage in ours. Just because you put it into the cloud doesn't mean it's going to get better. You've got to think about what you're putting up there, how you're going to build it, and how you're going to deal with it. Netflix did it. Netflix survived the outage. Why did they survive the outage? Because they had an approach which engineered for failure. Actually, there are a few things they still had to do. But there are reasons why they survived it. Their services are stateless. They don't depend on a particular server. They have data redundancy. They put it across zones. So if one zone fails, not everything is at risk. When the system does happen to have an issue, degrade the service gradually. Don't just kill everything off. Always keep spares, just in case something breaks. Think cloud, do cloud. Don't just shove the stuff up there and hope it works better. It may just fail more quickly and more elegantly. They also have, and this is the most interesting part, a chaos monkey. I think that's fantastic. They've built a service that goes around killing other services on their system to see if the system survives that. How many of you would be confident enough to put such a chaos monkey into your own systems? One. We know about cloud security, right? This is a done deal. We know that you need to protect your data in transit. Well, we've got HTTPS, so that's that solved, yes? Well, apparently not. You can break SSL with PlayStation. Who'd have thought PlayStations? Sony would be involved with some sort of breach using hardware. How bizarre. You need to protect your data at rest. We know about this. We can mention things about encryption. We also need to have people protecting the credentials that they get from their providers. But we know something about OAuth, we know about SAML, we know about authentication, identity, and so on. You need to secure your application. We know all these things. You've got to make sure that your OS is relatively hardened. People talk about bastion hosts. Right? You try and make the OS as tough as it can be. You put it into a container that's as tough as it can be. Where you do poke holes through the firewall, you put stuff behind it that makes sure it's as tough as it can be. What's often overlooked is designing for privacy. Worse than that, securing the wetware. How many of you know this term wetware? Okay, the rest of you are in for a nice surprise. This set, nicely covered in a document from Amazon on white paper on security best practices. These two I'll mention a bit more. We can keep calm and carry on at this stage because we know something about these. Protecting your data at rest, you can use encrypted file systems, you can encrypt individual files, but if you lose the keys, you're in trouble. If you lose the keys to your encrypted data, you cannot get it back again. You also have a cost of computation. So if you don't want to incur the cost of encryption, you can't encrypt your data. If you want fast encryption, you probably want it hardware encryption. Now, which systems do hardware encryption? Mainframes. So you're going to stick it in a mainframe. Okay. The grain size of encryption can mitigate against it. So you don't want to be encrypting each and every word of a file like this individually. That's going to incur a massive cost. You want to get the block size right for the encryption to work well, efficiently, and to make sure that losing your keys isn't going to affect a large proportion of your data in one hit. So you can encrypt certain segments of it, separate from others, with different keys, and run the risk only with certain of those. But what tends to happen? People decide that they need to protect their credentials, so they get something like this, a key locker. Right? You have one master key to protect them all. Now, if you lose that master key, you're in trouble, because all your keys are now gone. And this happened to another cloud service provider, LastPass. Well, it may have happened, but we're not sure yet. We'll see. The jury's out. This sort of thing is good for user convenience until such a time as it breaks. Now you can panic and freak out. In terms of privacy design, separation of data is an effective way to reduce the exposure. George Rees, who's written Cloud Application Architectures, and this is a book I use on my MSc module in cloud computing, talks about separating out credit card data from personal data. If you separate off the credit card information and encrypt that, all that somebody is going to get is a list of addresses. Once you need to use it, of course, you've got to decrypt it. There are other things that you can do within such a system. So now you have two pieces of data separated out, one of which is encrypted, one of which isn't, and you can associate them as you need to and only as you need to. Nobody with administrative access should have administrative access to both servers, or at least not in the same way. There should be restrictions between two servers on which this data is located. There should be different software on these two systems, so a breach of one does not imply a breach of the other is immediately possible. Neither system should have copies of the credentials required to get into the other. And you could also have a separate lookup table. So nobody has a means, if they obtain both sets of data, to associate the two unless they attack a third system which contains this. Obtaining any one of those three might not have so much value. But of course, this isn't just for cloud security. This is system architecture, reasonable practices. It should work. It's apparent that 77 million users of the PlayStation network didn't have Sony doing this. You could get the whole lot. You can get the addresses and the credit card details. They're not really designing that in anticipation of protecting the people. I don't know quite what they were protecting. You could separate it further. You can do more things. The more machines that you have, the more things you hack into, the more things you have to break in order to obtain all of this data and put it back together again. Whether you do it depends on how much you value your customers. In the UK, there's a maximum fine for data breaches of £500,000. 2 faxes cost you £100,000. Yeah. So there's a scale of cost that you should probably wear if you want to protect customers in ways that these people haven't. Instead of having this, why not design it from the ground up to avoid the situation occurring in the first place? If you encrypt your data, at some point you've got to decrypt it. Where's that going to happen? How are you going to do it? You've got to put a key next to it to decrypt it at point of use. Wow, hang on. We wanted the keys away from the data. Now we have to associate keys with data so that we can use it. You could try homomorphic encryption. Anybody understand homomorphic encryption? I'm going to keep my hand down. I haven't got a clue. It sounds expensive, it sounds difficult. Most people aren't going to do it for quite a while yet. You could use derivatives of your data stripped of metadata. Why do you need to associate metadata to it? Well, it's good practice. But if you're having it hosted somewhere, keep the metadata somewhere else. Can you derive things from the data that you can programmatically return the data to its original state with, so that the return, the de-derivation, is programmatic? Yes, you could argue that you can capture the system state and find out what the data is at that point of processing, but there are ways that you can get around having to have unencrypted, fully associated data on one server that is prone to attack. More tangibly than this, though, we're still panicking and freaking out because we do all of this and we've still got this wetware. We've got a human being that's going to do something. Now, how good are our human beings? How good are your human beings? Can you lock them down? Can you make sure that all the interfaces through them are controlled? Let's have a quick look at this. We've got two systems. This is kind of an academic exercise. We've got two systems. We've got a secure system over here. We've got an insecure system over here. So I can look at this one, and I can look at this one. I can become the interface. No matter how secure it is on this side, if I can interface it to a less secure system, I've just defeated that purpose of securing it. You can have secure VPC. You can have people at one end that can see all this lovely secure traffic coming through and can then take that data off it, put it into Twitter, put it into Facebook, put it wherever you want. The wetware becomes the problem. The more ability you give to your wetware, the more chance you have unless you've trained that wetware well. So a wetware bridge can work around a software, a secure software solution, and even a secure hardware solution. One thing that we've termed recently, and I checked on Google, there's no other mention of this, a data superinjunction problem. What we want to know is if some data, something has been exposed somewhere. What we can't do is use the queries from that data to try and find it. Because if we start querying on the things that we're looking for, then we're exposing the data. So we've referred to this as the data superinjunction problem because if I search for a certain footballer's name in relation to a superinjunction, eventually I might hit on the one that it is. But now am I in breach of the superinjunction? And if Google starts recording all these hits on the same one, are they in breach of the superinjunction? You'd want to be able to search for this footballer and superinjunction without exposing his name. How do you do that? Building the bridge between systems X and Y, so trying to search for the things that are being searched for that are in, say, a corporate repository, would expose it directly, and it would, in fact, remove the chances of having X as a more secure system than Y. Your security level is now at the level of system Y. What we need is a proxy for the data in X that we can search for in Y without ever revealing the queries from X. Wow. We need to be able to search for things without revealing what our query is. Yep, that's a challenge. We think we've done it, and I'll come on to that in a moment. If we can do it, we can have this proxy for X in the open. Corporate repositories can have a proxy for their data, and if another corporate repository happens to hold similar signatures for that data, there's a question to be answered. This is a very interesting challenge for us. And if we can do it in the open, we can do it in the cloud. Data superinjunction, we invented it. If you don't like the term, I don't mind. Give me a better one. So we might be able to find, without this superinjunction person putting things up on Twitter, who it is that the superinjunction is about, without ever revealing that that's what we're searching for. That would be fascinating. I'll come on to how what we've done so far in a moment. The wetware problem, according to a Detica Cabinet Office report, costs the UK £9.2 billion a year in terms of IP theft, which is greatly assisted by an insider. Somebody inside the organization who has access to all these wonderful systems, who has the freedom to do it, can then reduce the value to your business and, in fact, cause your business problems. Now, they could do that in a normal IT system. They could do that with a cloud system. Can you control it? Can you govern that problem? Report is there, and I can give the link to anybody who wants it. These data breaches tend to occur because of either the lack of intervention or with the intervention of a wetware. Somebody is doing it. How do you capture that somebody? Where you have rules about this, where you have acceptable use policies and things that people are supposed to read, sometimes they don't read them, sometimes they don't follow them. The rules can be ignored unless they are enforced. And this, I think, is where I would be at odds with the guy from Microsoft. Don't go trusting your loose wetware. Panic about them. It's only a loose cannon, but you've got to keep your eye on all the cannons. The problem smells like plagiarism. So you can throw a plagiarism detection at it. Well, most approaches to plagiarism detection encrypt each word individually. Actually, what they're doing is taking a moving window size over documents and encrypting each of those. So it has the scale of a document that's been encrypted word by word. Computational cost, very expensive. You can also generate an attack on this because if you know the window size, brute force will give you some bits of a document anyway. That's not a very good solution. We think we've solved it. We've got a paper coming out about this, but we can't tell you how we did it yet because of a super injunction. No, because we're looking for a patent for it. Patent for it, not patent. We're currently participating in a competition on plagiarism detection. We had, on Monday, we'd finished our results by Monday afternoon and we couldn't submit them until Tuesday. We were the first people to submit. Our approach to this is incredibly fast. We think we've solved it, we've still got to prove it. So we know about data problems, we know about some things to look for in security. If we're looking at cloud providers, we want to know things about regulatory issues, we want to know about security certification and standards, but pick your standards. We may look for things like a SAS 70 Type 2 audit and see whether certain companies offer this. Amazon certainly do, but critics claim that a SAS 70 Type 2 audit can be given without you revealing what it is that's being audited. So unless you know what's audited, you don't know what's actually secure. I don't know if Amazon have yet said what they include in their audit. There are security risks. ENISA's Cloud Security Risk Assessment is 123 pages long. If you feel you need to sleep, have a read. It lists some 53 potential vulnerabilities. These are things that you can check for with your providers, with your hat around all of these security issues and see what each one does. There's also Cloud Security Alliance guidance for critical areas of focus in cloud computing. So we know what we kind of need to look for. We need to do this per provider. In many cases, the cloud providers are doing a damn better job than some of the internal providers. If I go to my IT staff and say, what have we got of these? They'll think I'm talking a different language. Whereas I can go to a cloud and I can see exactly what it is that they're offering me. There is potential for new attacks. Do you trust the things that they're providing? If they're providing infrastructure, can you trust the instances? If other people are putting their instances up in some sort of ecosystem, how do you trust that? If it's the platform part of Salesforce, how do you trust the things that others have developed are not going to be leaking data back to them? Where do you build that in? If it's not possible to inspect it for yourself, and this was mentioned in the previous talk on jurisdiction, then can you be certain that it's trustworthy? There is also the distributed denial of service attack, which may lead to you having a denial of cache. If responding to network requests has a cost, and you're getting lots of denial of service attacks causing you network churn, then you're going to be paying for every single one of them. That could be costly. Some providers will obviously have systems that allow that not to happen, but you have to check what you're paying for when you do it. Cloud gives you different kinds of credentials, but the same social engineering problem. I think in the last Cloud Circle forum, somebody from Hertfordshire Council was here. Is there anybody from Hertfordshire Council here today? We can point at him if not. No. He said, when we had the data breach, we'd locked down all the IT systems. Who'd have thought the fax machine would be the point of breach? We didn't consider that as part of it. What he also said in private conversation was, one of the things that we do is make sure that our users are doing the right things with their credentials. What we found is if we lengthen the period of time over which people have to replace their passwords, they're likely to choose stronger ones. If you have them replacing them every week, they're likely to choose things that are more memorable because they have to remember it for the rest of that week and then remember something else next week. So some of the social engineering that we've done around security is potentially in the wrong direction. Now we come to the transformation problem. I was quite surprised last year to see this statement in a particular report from the Joint Information Systems Committee that deals with IT for developments in IT for education. Of those institutions currently not using cloud computing, only 2 are not currently considering cloud services. University of Surrey, Uxbridge College. I think it's the only time University of Surrey and Uxbridge College have appeared together in a sentence. That wasn't the reason for surprise. The reason for surprise was that I was working on this report on cloud computing for research at exactly the same time. But that's not necessarily a reason for surprise. By the way, this is shameless plug number 2.5, in case nobody spotted it. We know what cloud computing is about. We've done some research into how to use it for research. We haven't covered yet the security aspects of it within there. So I was kind of here. Our university isn't going to do cloud. We're all doomed. Sick feeling in the stomach, slight area of panic, press a little button. But there's a reason for it. The reason for it is probably in the divide between these two. The business services versus the research and experimental students. Now, I'm probably in a generation where experimental in a sentence with student means something entirely different. Dangerous, in fact. Business services tends towards vanilla. Any flavor as long as it's vanilla. We want it to be simple, straightforward. We want it to be a certain version of a certain operating system with certain applications. And if you want to do anything else, ha 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 ha. Everyday business supporting functions have to be maintained consistently over extended periods of time, and so we need it to be locked down. All well and good. Potentially some scope for sector-based brokerage and consolidation of such services, and I'll come on to that in a moment. One big data breach here, and all this data goes out, so we haven't asked questions about how well that's engineered. On the other side, we've got this research angle where things are chaotic. People want to do ad hoc work. Some of it's relatively well defined. Domain-specific high-performance computing is available. Amazon offer HPC instances, and you can set clusters up very quickly. Below that is everything else, moderate chaos. People just want to try stuff out. So for us, we were looking here. The cloud computing for research was in this area. The other report, people were being asked about business services. But even that's a slight element of surprise. What it comes to around here is the reluctance of certain system administrators. Now, I'm in a mail group for computing at school. And it's apparent from teachers in schools that system administrators in schools, not all of them, some of them, are concerned that students from the age of 16 or even 14 will be able to cause mayhem and bring their systems to a standstill just by running a few programs that they've written. These people either vastly overestimate the ability of these students, or there are much worse concerns for their systems than simply these students. But it shows a reluctance. This is a particular reluctance, and if you really want to scare university IT staff, mention the University of East Anglia's climate change data. Now panic and freak out. So this is the standard model for IT within a university, a fairly simplified view of it. There are these things called users. They are awkward, they get in the way. There are these people called system administrators. They try to stop these people from doing much. These people keep asking them questions and they say, I can't do that. If you get through these people, you get access to things in the data center, and eventually you get those services and you're able to make use of them. That's all right. We know this. We're calm about it. We can accept it. You've got a nice layer in there that's going to prevent anything silly from happening. As Dilbert cartoons would have it, for Mordack, the preventer of information services, security is more important than usability, and in a perfect world, no one would be able to use anything. People might evaluate cloud. and say, well, it might be suitable, but we don't want to do any real work, so let's just say we're evaluating it, and that would have satisfied that particular report. Carry on as you were. We have this tension, though. In university environments, computer labs are provided as business services. What we want is our experimental students using those computer labs to do relatively chaotic things. This looks like Mission Impossible. Well, it doesn't. It looks like a mouse being upside down. I don't know what's going on there. This is what we want to do. What's missing? The people stopping us from doing it. We'd like to remove them from that loop. We'd like to. They'll be reluctant, but we'd like to. In attempting to do it, we will try to use certain technologies. When I asked whether I could have students able to provision their own systems to act as a root user, as an administrator for those systems so they could develop anything, after the person I'd asked got up off the floor laughing, we had a nice conversation about the kinds of systems that we could get to do it. And this guy is eating one of them, eucalyptus. It didn't scale, it leaks IP addresses, and it goes wrong quite often. So when choosing private clouds, be very, very careful which one you choose. You may not end up with a very nice result. But if we're going to do that, we need to trust the end user. We need well-educated end users. We're back to educating the wetware again. We can have all the security stuff we like in the world, but the more we allow to be done, the more we have to have the better educated users to be able to do it. It's possible to consolidate systems so that we reduce the amount of effort that goes into doing it. And University Modernisation Fund money is going into EduServe to pilot a data centre. My emphasis on a data centre. Why would you want to pilot a data centre? Surely you want to pilot 2 data centres. Where's your redundancy? We can consolidate. G-Cloud is going that way. We can broker. Who buys a kiln so they can build houses? You start with bricks, right? If services already exist, why think you can build them any better and cheaper and easier? Some organizations are doing this and outsourcing things like email to Google, Microsoft, and so on. We know about all of that. What of all the other largely similar cross-sector business software in universities? Well, that's why this is coming about, but this isn't necessarily the right direction. It's interesting to see the current criticism of G-Cloud is that G-Cloud is merely doing consolidation. David Wild of Westminster City Council says that's not the way to go. The National Audit Office, I think, has a report on this as well that says G-Cloud hasn't gone anywhere. All this stuff is available. Why not use it? Why not broker it? Why not get the best prices? And why not squeeze the margins on it? So what do we do? Lost, confused, unsure, unclear, perplexed, disoriented, bewildered. Are you any the wiser yet? Probably not. We can bring in expensive consultants. Cloud will reduce your IT spend, making more money for the fat cat consultants. That's fine. This is a slide from Simon Wardley of the Leading Edge Forum. But is that solving our problem? Do we have the better educated users at the end of it? Or do we simply transplant the technology problem? We haven't yet fixed the security issues. We've simply moved them into the cloud. Whoops. One day it might be solved. Today is not that day. Shameless plug number 3. We've got a journal on cloud computing, and hopefully at some point in the future there'll be certain articles about security within that. So I'm going to come back to my caveats. I probably haven't answered any questions for you on cloud security. I've probably given you lots more questions to ask about cloud security. I'm not a Chief Information Security Officer. I am a relatively knowledgeable, I think, end user. Some of these things concern me, some of them don't. For obvious reasons, some of the views shared may not reflect those of my organization, and the presentation was put together at short notice, and I'm happy to extend this list depending on how annoyed you appear to be with what I've said so far. I think I've got away with most of it. So I'm prepared now for questions for as long as we've got left, and I may even be able to give answers, or I may not. But thank you for staying in here.